This is part 2 of 2 for August 8th, August 9th notes, talking about vertical shifts of sine and cosine. We already went through the first page, talking about reflections, amplitude change. Go ahead and go over a few problems on the back. So I'm going to quickly talk about these two. If you want to pause it, see if you can understand what's really happening with these two graphs. But here, what's happening is this negative, what we could say is, if we went ahead and graphed the parent function sine, then we would reflect that function across the x-axis because of the negative sign here. Our amplitude would change. Our amplitude here would be 3. Because we're multiplying by -3, but we take the absolute value of that, so our amplitude would be 3. And then hopefully we can remember from last class that if we add a value inside of our parentheses, that tells us move left or right. Since we're adding, it actually means we move to the left. So we would shift pi over 3 units to the left. Okay. Let's talk about this one. This one gave people some issues. Let's start with the 1. So if we graph the parent function, we know we would shift again to the left 1 unit. Now the 4 and the 5. Last class we said if we add or subtract outside of our function, that means we moved up or down. But we can't add the 4 and the 5. Similarly, we can't do 4 plus 5x. Those can't combine. Same thing here. So what we would do is we would say we would shift up 4 units. And then this 5, since we're multiplying our parent function by 5, that means our amplitude would increase to 5 because we're multiplying by 5. So this is in words what's happening to our function. And just to kind of clear it up, we would actually need to move it up before we apply, or we could do either. But what's happening is if we wanted to figure out our range, you know it's going to touch a value. Well, we would shift it up 4 units. So if you think about the center of our function, the center of our parent functions is here at 0. We shift it up 4 units, so all visualization right now. And then our amplitude is 5, which means from 4, if the function is here at 4, it's going to go up 5 units. So the highest value it's going to take is 9, because 4 plus 5, 4 up 5, so 4 plus 5 is 9. It's also going to go down 5 units. And 4 minus 5 will give you -1. So our range would be -1 to 9 because we have to shift it up 4 units first, and then the amplitude goes from there. We could also do the amplitude here and then shift it up 4 units. Same thing. Now, what does this look like? Well, let's go through 2 problems. So here we have sine of x. I'm going to go ahead and label my axes. Sine 1/3 sine of x, sorry. So I'm going to label in both directions. It gets a little tight over on this side. Let's call this 1. Let's call this -1. Draw the parent function. So because we're dealing with the sine starts at 0. So we're going up to 1 and then down. So this is our parent function. Alright. Now, what's happening is this 1/3, our amplitude, because we're multiplying our parent function by 1/3, will be 1/3. So let's think about ways we can do this. Well, if this is 1, then maybe if I do cut it into thirds, 1/3 is 2/3. So 1/3, 2/3, 3/3. -1/3, -2/3, -3/3. And now what's happening is this value, this function value is at 1, well, now it's going to be at 1/3 because that's our new amplitude. So this is that point. Our zeros stay the same. If you think about it, if sine of pi is 0, then 1/3 times that 0 is still 0. Or in other words, you would have sine of pi, which is 1/3 times 0, which is 0. Or in other words, these zeros stay the same. All that's happening is this -1, we're like compressing it. We'll go to -1/3. This +1, +1/3. This -1, -1/3. All because our amplitude changed to 1/3. And now we draw the curve that goes through those points. So it's the same curve, but our amplitude changed. Our amplitude changed from 1 to 1/3. And this graph actually looks pretty cool. Alright. So that would be our amplitude in our new function. I'm trying to do this one quickly. There's a lot of ways you could do this. If you want to pause, try it, and then see if you end up with the same thing, that might be good. Similar to the one on the front page that we looked at, the -2 sine, -2 cosine of x. Yeah, that's positive. I'm then making an observation. We're multiplying by -3. I'm going to say that we probably need to go to 3. Alright. And again, parent function. So 0, let's go ahead and draw the parent function. Alright. Now, the negative means that it's reflecting. So in other words, if we were just to reflect it, this value would be here. This value would be there. This value would be there. That value would be there. But our amplitude changes. Our amplitude changes to 3. So if this value was here, if we just reflect it, if it was just negative sine of x, then this value where it's 1 would be at -1. It would be here. But our amplitude changes to 3. If it was here, our amplitude would still be 1. Here, the amplitude 2. Here, amplitude of 3. So this is where our point would be. Similar concept here. If we still need to reflect, so this value would be here at 1, but our amplitude is still 1. Amplitude 2, amplitude of 3. Amplitude of 1, 2, 3. Here, amplitude of 1, reflect, amplitude of 1, 2, 3. Our 0 values stay there. And so our new function looks something like this. Alright. So we need to be careful on these because we do need to reflect and the amplitude needs to change. Alright. I'm going to get you started on this next one. If you have questions about these two, please email me, ask me questions. Here it might be helpful to actually draw a dotted line with the amplitude of 2. So go ahead and be like 2, -2, and draw your parent function from there for cosine, and then shift it up 2 units. Because you will need to shift it up 2, and your amplitude would need to be 2. So be careful on this one. There's a lot of ways you could do it. As long as we perform the operations in sequence, that's fine. Also, you could just obtain ordered pairs, plugging in the values 0, pi over 2, pi, 3 pi over 2, 2 pi. You get the same function. So try that out. If you have questions, please feel free to email me. Use the reminder, all the resources that you have available, please use those.